When we think about AI, our minds usually jump straight to things like chatbots or those wild image generators. But what if I told you that some of the biggest, most important breakthroughs are happening way outside the typical tech bubble? Today, we're going to look at a totally new frontier, a place where AI is being created at the intersection of completely different scientific fields.
All right, let's just jump right in with a bit of a puzzle. What on earth could a washing machine, a super advanced jet engine, and the human brain possibly have in common? I know, it sounds like the setup to a really weird joke, but the answer? Well, the answer points to the next great leap for artificial intelligence, and trust me, it is not what you think.
So here's the thing, the fundamental challenge we're facing. Our current AI models are incredibly powerful, no doubt, but they can also be kind of brittle. They need massive amounts of clean, perfect data to work well. The problem? The real world isn't clean or perfect. It's messy, it's unpredictable, it's full of gray areas. We really need a new kind of AI, one that can handle all the uncertainty and complexity that life throws it at it.
So how do you teach a machine to think in shades of gray? Well, our first stop on this journey is a bit of a surprise. It's a blend of applied mathematics and linguistics of all things. The concept is called fuzzy logic, and it's all about getting AI to move beyond a world of simple yes or no answers.
To really get fuzzy logic, we first have to look at its complete opposite. See, traditional computing, the kind that's in your phone and laptop, is built on binary logic. Everything is either true or false, on or off, a 1 or a 0. It's like a standard light switch. It's either all the way on or all the way off. There's no in-between. Simple and clear, right?
But fuzzy logic, now that's a whole different ballgame. It's like a dimmer switch. It allows for things to be partially true. Instead of just on or off, you can be kinda on or mostly off. And that one little shift allows the machine to handle concepts that just aren't black and white. The way we humans do all the time. This is an absolute game changer for dealing with real-world ambiguity.
And this is where that abstract idea becomes incredibly practical. Check this out. Fuzzy logic basically acts as a translator, turning our vague, everyday language into commands a machine can actually use. So, slightly dirty clothes tells a washing machine to use a medium water level. Slightly uphill terrain tells your car's cruise control to give it a little more gas. It's the perfect bridge between our intuitive human world and the super precise world of a machine.
Okay, so let's take that idea from the world of software and bring it into the physical world. We're heading into the factory of tomorrow now, a place where AI is merging with mechanical engineering and data science to create something truly revolutionary.
At the heart of this revolution is a concept called the digital twin. Just imagine having a perfect, real-time virtual copy of a physical object, like a jet engine or even an entire factory, running on a computer. It's kind of like a hyper-realistic simulation where you can test things, push the limits, and try out new ideas without any real-world risk.
And what can you do with this digital copy? So much. Companies like General Electric use them to monitor jet engines while they're flying, tweaking performance and even predicting when a part might fail weeks in advance. Siemens has a platform called MindSphere that does the same thing for huge industrial machines. It's basically like having a crystal ball for your equipment.
So, does all this virtual work actually make a difference out here in the real world? Oh yeah. The answer is a resounding yes. At one of Bosch's AI-powered plants in Germany, these smart systems cut their defect rates by more than 20%. That is a massive tangible impact on quality and efficiency, all thanks to this synergy of different technologies. All right, we've gone from huge factories, and now we're going to zoom all the way in to the most complex and efficient machine known to exist, the human brain. This is our third and final frontier, where AI is looking directly at nature for inspiration, borrowing designs from neuroscience and electrical engineering to get way more powerful and efficient than ever before.
This slide really gets to the core of the difference. Your typical computer has a processor and memory that are separate. Think of it like a chef who has to walk all the way across the kitchen every single time they need an ingredient. It's a huge bottleneck, it's slow, and it wastes a ton of energy. But neuromorphic, or brain-inspired chips, they're totally different. They put the memory and the processing right next to each other, like having all your ingredients right at your cooking station. This lets them process tons of information at the same time, in parallel, just like our brains do, with incredible power efficiency.
And this completely new hardware allows for a new way of thinking. It's called a spiking neural network. So instead of processing a constant, heavy stream of data, these networks, like the ones in IBM's True North chip, operate on these brief spikes of information. Think of it like a conversation where you only speak when you have something important to say. They fire only when they absolutely need to, mimicking our own neurons and making them insanely fast and efficient for things like robotics or real-time sensory processing.
So we've journeyed from fuzzy logic to smart factories, all the way to brain-like computer chips. 3 really different worlds, right? But there's a single powerful idea that connects all of them. Let's bring it all together and finally see the big picture.
This right here, this is the heart of the whole thing. Do you see the pattern? Not a single one of these breakthroughs came from computer science working alone. Fuzzy reasoning needed applied math and linguistics. Intelligent manufacturing needed mechanical engineering and data science. And brain-inspired intelligence is a direct result of neuroscience, psychology, and electrical engineering coming together. The future of AI is not being built in a silo.
It really all comes down to this powerful idea from the source material. The evolution of AI will be defined not by isolated advances, but by the synergy of knowledge across domains. The real innovation, the stuff that changes the world, is happening at the boundaries, where completely different fields collide and create something entirely new.
And that leaves us with one final, kind of awe-inspiring question. We've just seen what's possible when AI converges with only a few other disciplines. So just imagine, what problems could we solve if AI learned to collaborate not just with a handful of fields, but with all of them? The possibilities are, well, they're truly limitless.